All right, here we're in day 2 of section 3.2. We are now looking to solve some word problems that involve systems of equations, okay? And I'm going to walk through a couple examples with you, and then you got one practice example to try yourself, okay? The first example is referred to as a break-even point analysis, all right? And this is kind of a simplistic business application where a linear system of equations would apply, okay? So read through the scenario here with me. We have a service club selling copies of its holiday cookbook to raise funds for a project. The printer's setup charge is $200 and each book costs $2 to print. The cookbooks will sell for $6 each, and we want to know how many must the club sell before it makes a profit. How many must the club sell before it makes a profit? Okay. So there's a couple equations that we can come up with out of this scenario, right? But before we determine the equations, I always like you to begin a word problem by defining variables. And for system problems, you should have two variables that you're defining, okay? So I'm going to make X the number of cookbooks. X represents number of books. And then I'm going to make Y money, okay? So the first equation that I can come up with in this system, I'm going to refer to it as the cost equation, okay? An equation to represent the cost of making these books, all right? It would be equal to Y equals 2X plus 200, okay? So what that's saying is I have to pay this upfront charge of $200 plus $2 for every cookbook that I sell, and that's going to determine the cost, the total cost of making these books. Okay. My second equation I'll refer to as my sales equation, and this is simply going to be how much money is brought in by the sales of your cookbook. Okay. You're selling them for $6 each, so simply would be an equation of Y equals 6X. $6 per cookbook equals how much money I generate in sales. Okay. All right. So now I want to graph this system to give you a nice visual of why this is referred to as a break-even point analysis. Okay. Both my equations are in slope-intercept form. I'm noticing the first equation, the cost equation, has a y-intercept of 200. So I'm going to have to scale my grid here accordingly, okay? So I think what's going to be best is if we make the whole grid represent the first quadrant, which is typically all you need in a real-world application setting, okay? And I think it would be best to make both the X and the Y axis go by ones here, or I'm sorry, by 50s here, okay? So my X axis label by 50s. And this is representing the number of books. So we would definitely want to label. And then same thing for the units on the y-axis. This is representing your money. Okay, so let me do the cost equation first. It has a y-intercept of 200, and then the slope is 2 units, okay? So I can rise 2 units, which is a total of rising $100, and then I can run 1 unit, which is running 50 books. So if you think 100 over 50, that simplifies to 2, right? Okay. Then we'll do our sales. Our sales has a y-intercept of 0, and a slope of 6. So I'm going to rise 6 units, run 1 to the right. Okay. And the intersection point is what we care about here. All right. This is my break-even point. It's where the amount of sales is equivalent to the amount of cost that you've put into the project, okay? And that appears to be the point of 50, 300. All right, so that means we're going to have to sell more than 50 books in order to make any sort of a profit here. Okay. All right, now I took a graphical approach to start, just as a nice visual of why it's referred to as a break-even point. However, that a lot of times is more work than necessary. So we could have also solved this system very easily with substitution. Since both equations are already set equal to y, I could have simply said that 2x plus 200 is equal to 6x, and then solve that for y, or I'm sorry, for x. And I would have ended up with the x equals 50. And then I could just plug in 50 for x. I'd probably use the bottom equation to get my dollar amount of 300. Okay, so that would obviously be much quicker to algebraically do than to sketch out the graph. Okay, moving forward, our next example. Bethany has a bakery. She sold one customer 8 dozen chocolate cookies and 1 dozen oatmeal cookies for $58. And then the bakery also sold another customer 3 dozen chocolate cookies and 10 dozen oatmeal cookies for $118. So how much does 1 dozen of each type of cookie cost? Okay, I think the question there that's being posed is really important for helping us to understand what our variable should be. I'm going to say that my first variable x is the cost for 1 dozen chocolate cookies. And y would be the cost for 1 dozen oatmeal cookies. And notice how specific I'm being there. I'm not just saying x equals chocolate cookies and y equals oatmeal cookies. I'm being very specific in that these are representing 1 dozen of each. Okay. Now it's time to make my system of equations. Okay. My first equation is going to represent that for customer 1. All right. We sold customer 1 8 dozen chocolate cookies and then 1 dozen oatmeal cookies for a total of $58. So 8 dozen chocolate cookies times the price per 1 dozen chocolate cookie added with 1 times the cost of 1 dozen oatmeal cookies is a total of $58. And then I'll do something very similar for customer 2. Customer 2 is buying 3 dozen chocolate cookies, so 3x, and they're buying 10 dozen oatmeal cookies, which is 10y equals 118. So notice in the end, both of these equations are just representing the amount of money that's being spent by each customer. Okay. All right, now we'll solve this equation or system algebraically. I think this one is perfect for substitution with the fact that first equation, you have a coefficient of 1 on y. So I'm going to take this and I'm going to make it y equals negative 8x plus 58. and then I'm going to substitute that into the second equation for y. So that's going to lead me to 3x plus 10 times negative 8x plus 58 equals 118. Solve this now for x. So we'll distribute. Get my variables combined, constants to the other side. Divide that negative 77 over, and I end up with x equaling $6, meaning $6 per dozen chocolate cookies. Okay. And then I want to know what's the cost of the oatmeal, right? So I'm just going to take the $6 and I'd probably plug it in right here in order to solve for y. And that's going to lead me to $10 per dozen oatmeal. All right, there you have it. All right, so now it's your turn. Pause the video, you try the next practice problem yourself. Start by defining your variables, making your two equations for the system, and then solving by a method of your choice. When you're done, come back and check your work with mine.